Hello, this is Sharon Fisher, and Teledyne ISCO would like to welcome all of you to our webinar, Flow Meter Maintenance is Vital, Warning Signs and a Proper Diagnostic How-To. Today we are being joined by Daryl Kuda, who is one of our regional managers, and he has a great deal of knowledge with our flow meters. Just to mention a couple of items, if you happen to have any issues with video or audio, please leave the webinar and rejoin. That typically will clear up this issue. We will have a Q&A time at the end. So as you think of questions, please enter within the questions box and we will get to those. The webinar is also being recorded and we will be making that available in the near future. So with that, I would like to welcome Daryl.
Hello, Sharon. Thanks. Yeah, I look forward to talking to everyone today about the flow meter maintenance. There's a lot of good reasons to maintain your equipment just to increase your uptime and provide reliable equipment. And so got a few slides that I want to show you and hopefully gain a little knowledge on the importance of maintaining your equipment. So today's agenda, I want to talk about why maintenance is mandatory. Desiccant maintenance is going to be a key focus of this presentation. And I want to also discuss the warning signs for when you need to clean your sensor or flume. So the idea is to help you determine if it's a sensor problem or if it's more of a maintenance issue. We'll discuss the differences between both. Then when you use condition-based maintenance, so using the tools that you have available, for your level, temperature, signal strength, any diagnostics, use that as a means to determine when to do maintenance instead of just a standard operating procedure and, going out there every 2 months just because the calendar says you should go out. And last, we're going to cover using an alarm as a maintenance reminder. And we'll also cover the importance of updating firmware and software, and I'll give you some tips on that at the end of this presentation. So let's start with why is maintenance mandatory? One, it increases the production uptime, or the product uptime, improves the data reliability, it extends the life of your product, and it saves you money in the long run. As we all know, maintenance is an important aspect of life. As far as, for example, maintaining your car with regular oil changes and checkups will extend the life of your vehicle. Same goes for flow meters. The better the maintenance, the longer the life of the sensor and your equipment. This saves you money in the long run by not having to extend your flow study, because if you had some problems like in this picture, if we had sediment covering that sensor, we would no longer get velocity readings. So you may have to go in there and clean it and then, redo your flow study or extend it. But if we can catch this early and clean it before there's an issue, it's going to make you a lot more effective. And then, going back to this picture, if you start having sediment and debris and stuff covering your sensor, that could, there's a potential it could actually damage your sensor, which then that's going to cost you more money. And that's where maintenance is going to save you in the long run. One, it's going to speed up your flow study, and it's going to help make sure that your equipment is running properly. It lessens the chance of it getting damaged. So there's a lot of benefits to maintaining your equipment. Now, one of the main things I want to talk about is the desiccant maintenance. So desiccant is really important. It extends the life of your product. It helps improve the data reliability, prevents drifting on your pressure sensor, and then I'm going to cover in a few slides here, using trends, looking at the level, temperature, humidity, and all those things can be used as ways to determine when you need to change your desiccant. So as you can see over here, the importance of desiccant is actually to help keep your components, electronics dry. So on the inside of your instruments, you may have loose desiccant beads, or you may find that it comes in a desiccant pack, or even possibly a vent tube, depending on what equipment you have. And so, the idea of the desiccant is it actually draws in the moisture to help prevent any type of corrosion within your equipment. Now, as far as the other thing, the equipment that you put down in your collection systems, there's usually a lot of high humidity in the sewer systems. And so you want to make sure that you're using a flow meter that's IP68 rated, so it can handle the high humidity. But, most flow meters are designed that way, but, there is always a chance for a little bit of air to leak in there, and that's where that desiccant's going to help minimize any type of corrosion. So the way this saves you money in the long run is, by maintaining your desiccant, keeping your electronics dry, free of any type of corrosion, is going to extend the life of the equipment and then minimize your costs so you don't have to replace it. Now, what I like to look at is the trends that I had mentioned. Some of the things that you may find is that the level can actually drift. So if you have a pressure transducer, one thing you would look for is, see if the level, remains constant, follows the same diurnal pattern that you're used to, or you may find that your velocity remains consistent, or even that the level goes below zero. So an example here, as far as with the level drifting, if your desiccant was plugged, either from debris, moisture, excessive moisture, what you'll find is that your level may actually go above and below zero. And what happens there is that pressure transducers usually have a referenced atmosphere, which goes through that desiccant tube. And if it no longer references atmosphere, as the barometric pressure changes, you will actually see your level going above and potentially below zero. And so one way to test this is you can take your sensor, put it in a bucket of water. It's going to have a constant level minus a little bit of evaporation. But throughout the day, as the barometric pressure changes, you would actually see the level increase and decrease with that pressure because it doesn't have the referenced atmosphere. And so that's usually an indication that the desiccant does need to be replaced. And the other thing you may notice with the velocity remaining the same is that, like on the Teledyne ISCO AV sensors, if the level were to drop below zero, it stops trying to read the velocity, and so you'd end up just seeing a flat line on the velocity because the level is too low. Now, let's take a closer look at this. So this is the pressure transducer that's in the area velocity sensor. It's a piezo-resistive transducer, and it has a referenced atmosphere. And so normally what happens when it referenced atmosphere, the pressure transducer just changes the level reading based on the static or the head pressure over the top of the sensor. If the reference line is blocked and no longer has referenced atmosphere, as the barometric pressure increases and decreases, it will actually, contract or expand that diaphragm, causing your level to change. Now, a couple other things as far as with this desiccant. Now, with our equipment, we have a Gore filter, as you can see here in that bottom middle picture. And what that Gore filter does is added protection for the desiccant. So if the unit were to go underwater, the Gore filter or a hydrophobic filter will actually prevent water from getting inside of the desiccant tubes. And so in the event that the meter does go underwater, it's submerged, due to high water levels, the one thing you'll want to do is pull out your desiccant tubes, replace the desiccant beads, and I recommend replacing that Gore filter because by design, it's supposed to plug to prevent water from getting inside the system. Another tip for you is that when you attach the sensor to your logger, as shown here in the top middle picture, When you remove the cap from the logger and then remove the cap from the AV sensor, you should connect the two of them together, and that's going to create an airtight seal between those two caps. And the reason is that what I found is that if you left the caps disconnected, you're going to find that moisture is going to collect in the end of those caps because it's just been sitting there in that very humid environment. And then when you go to remove the system, you disconnect the sensor, you take that cap with the the moisture built in there, and then you put it on the end of the AV sensor. Now you've actually forced water into the pins, into that reference line, and the next time you go use it, now you have drifting. And then the other side, if you take this cap and put it on there, now you've actually just induced water into that connector. So again, to prevent that from happening is when you connect the AV sensor or any sensor to the logger, take the two caps, put them together to create that airtight seal. That way you don't accidentally introduce moisture onto the sensor or the equipment later. So let's discuss some of the warning signs for when to clean your sensor or the flume. Again, look for trends. And so what we're looking for is you should have a normal diurnal pattern during normal flows. It's going to change during the wet weather. You want to look for dropouts in the level, velocity, signal strength. Other things to look for is unexpected increase in total flow. So if it's a flume or a weir, it uses a level to flow lookup table. If there's a blockage, you're going to see that your flow rates are going to increase. And then we'll discuss how this is going to save you money here in the next couple slides. So when I mentioned looking for dropouts, so I'm looking for the trends. So a couple things here is that when you're looking at the green velocity down here on the bottom, is that over time, you're going to see that you have good velocity readings going up and down. But then if you start seeing that you start getting flat spots, that's usually an indication that it's just holding on to the last known reading because it was having trouble getting a velocity reading. And usually the cause of that is that if you're starting to get sediment building up on the front of that sensor, you're going to see that a little bit of sediment covering the front, you're going to get a few dropouts, but the more sediment that covers the sensor, then you may find that it goes into complete failure. And so that's what you want to look for is either readings just going down to zero or flat spots, because there's no way that velocity is that consistent that it would stay reading the exact same reading for hours at a time. Things that could cause some of those type of dropouts could be that there's a blockage downstream, or the sediment, or it could just be debris coming through the collection system that temporarily covers the sensor. Other things to look for is going back looking at the trends. If you were only looking at the flow rate, so down here in blue, you may not notice that there's any type of a problem. Because the flows remained fairly consistent down here. But if you take a closer look at the other data that you have available to you, like in this case, you see our level was averaging about 25 inches, and then it jumped up to around 35 inches. But then the velocity did just the opposite. And what that's an indication of is that there was a gate or debris or something downstream that was restricting the flow going through there. So we still have the same amount of flow coming into the system, but the problem is it was blocked downstream, so my level goes up, my velocity goes down, and then all of a sudden somebody either opened the gate, cleaned out the sewer system, and then the level goes down to normal, velocity increases due to free flow. So this is something you can look for to determine when maintenance may be needed. So the flow rate wasn't a great indication of it, but looking at the individual parameters, level and velocity would tell you that as well. And so next we go on to the flume. So some of the warning signs on that would be, that's one place where you could look at the flow rate, because what you're going to see is that if your flow rates were normally at 1 or 200 gallon per minute, and then all of a sudden it shoots up to 1,000 gallon per minute, that's an indication, like what we're seeing here, is there was a blockage. And so Flumes and Weirs just use a lookup table. They just look at the level, look at the table, and then give you the flow rate. So they don't have the ability to read velocity. So that's where looking at the flow would help. You could also look at your level readings, because you're going to see that your levels were normally low, and then all of a sudden now they've tripled or quadrupled. That could be another indication that there's a problem with that, a blockage within your flume. Other things you may notice is that, like looking at the ultrasonic signal strength, you may find that in this case, the signal strength actually went up, because looking at this picture, the water is fairly smooth when it's higher, and when it was lower, it may have been just a little bit more turbulent. And so you may see that it went from like 80% up to 90%. That could be another indication telling you that that there's some type of a blockage in that flume. Now, as far as where this is going to save you some money, is that if you catch this soon enough, you're going to have accurate flow readings. In this case here, it's calculating flow based off the 100% full flume, which is in a surcharge condition, which is then over calculating your flow. So if you're billing on it, now you're over billing, because you're incorrectly calculating the flow going through there, when in reality you only have a couple hundred gallon per minute, but based on the flow table, it's showing you that it's maybe 1,000 or 2,000 gallon per minute. So next, I want to stress using condition-based maintenance instead of just a standard operating procedure. So a lot of you go out on site every couple of months, every quarter, just because the SOP just tells you that's when we have to go out there. And you go out there, you look at it, everything's fine, change the batteries maybe, but you could save money in the long run by actually using the diagnostics. And so that's what I've been trying to stress, is that use what you have available to determine when you should go out there. Start looking at the diagnostic graphs if you have them, the signal strength and the level, on area velocity sensors or ultrasonics. Other things you can look at is the temperature, or you can even use the diagnostics again, which I'll show you. As far as like using the temperature, that could help determine if there's a if you're seeing added flow, it could possibly be due to industrial discharge from a boiler or washdown. If you notice your temperatures, like an ultrasonic sensor starts to go way up, or really low, ultrasonics use temperature to compensate for the speed of sound. And so if your temperature reading's off, it's going to affect your level reading, and then that could either and result in calculating higher or lower flows. Same thing with a pH sensor. It uses temperature as well, and so your pH readings could be off if your temperature is off. So just another tool that you could look at. Other things you may notice by looking at your diagnostics is that on your level readings, if all of a sudden you start finding that your readings are dropping in half, or maybe even going negative, one thing you may find is that you could be receiving a double echo. So what happens is that the ultrasonic sensor transmits a signal, bounce off the surface, comes back. Usually, like right here at around 25 inches, it tells me it's 25 inches away from the sensor, and that's my level reading. But on occasion, you may find that an ultrasonic sensor has a secondary bounce, and so it picks up this one. And so what this is telling us is that it thinks the level is roughly 50 inches away from the surface, thus giving us a negative level. So the way to get around that is, like on our equipment, you can actually adjust the blanking distance. So I can tell it I have a minimum of 1 foot blanking to the surface of the water, and a maximum distance of 40 inches. That way it focuses just on this area instead of that double mounts, and that's going to give you more accurate readings. Other diagnostics that you may have, like on area velocity sensors, is the signal strength. So in short, what that is, it's the amount of reflected energy received. And so think of it as the gain applied to receive that signal, like a hearing aid. How much do you have to turn that hearing aid up to be able to get a good signal? And so that's our signal strength. What I find more important is the spectrum strength, and it's the indication of the true velocity signal versus return noise. So I got my hearing aid turned up, and how much of that am I hearing back? If you're recording that information, usually what you're going to find is that the range is going to be between 40 and 60% is pretty average for the signal and spectrum strength. Because with a hearing aid, you don't have to have it turned all the way up 100% to be able to hear something back. You maybe only have to turn it up 50%. That way you can get a good return signal. Now the spectrum ratio, what that is the indication of the weight of information of the direction of flow. So simply stated, it's just looking at what direction the flow is going. So this is the one place where you may see the spectrum at 100%, indicating that it sees 100% of the water coming directly at it. If there was some debris in front of the sensor, start creating some swirling, that's when you're going to see that the ratio start to go down. And this could be an indication of when you need to go out and do maintenance and clean your channel or the sensor. Because if it's the trend is normally around 90 to 100%, and then all of a sudden you see it starting to decline down to 60 to 40%, that may be your trigger when to go out there and clean off debris. Now this graph, what we're looking at here is I'm looking at the flat lines in data, and it doesn't necessarily mean that it's a maintenance issue. It could just be part of the application. Some things that could cause like a flat line in your velocity readings, maybe the level's too low, because AV sensors need about 1 inch of water or more to be able to transmit their Doppler signal and get a reading. So if the level drops too low, your velocity is going to drop out, or possibly the velocity is too slow. A lot of velocity sensors, if you get less than a half foot per second, they struggle to tell the difference between the signal and noise, and it may drop out the signal. Now, depending on your equipment, you may have it set to either interpolate velocity below a certain level, or if it goes into error, you can have it go to 0, or you can hold on to the last known reading. So in this case, what we're looking at with the flat lines on here is it's holding on to the last known reading. Other ways to determine that you may be having some problems is if you like using a scatter plot, you start seeing what some people call corn rowing, just an indication that it was just holding on to that last known reading, giving us those for the velocity. So even though level was changing, it maintained that same velocity reading. Normally on a scatter plot, what you want to see is more of a just more of a trend that just goes from the bottom left to top right. It's more of a cigar shaped as opposed to what you're seeing right here. But it's just another tool that you have available to see if when you should do maintenance. Now, as far as cleaning the sensor, what I recommend on an AV sensor, you can remove it and just use tap water. You could use a brush on the top of the sensor, but do not use a brush to clean the actual diaphragm. They're very sensitive. When you're cleaning the actual diaphragm itself, you should just run tap water over it, flush it out to clean any debris out of there. Now, other things that you can do, if you find that you have an application where you're constantly going out there to clean it because either you're going out there on a regular basis and you have to clean it, or 2, you're using the diagnostics and see that it keeps getting covered up with sediment. One thing you can do is offset your sensor. So instead of having it at the bottom where it could get covered with the sediment, just rotate that up off the side. And this is depending that you have enough water depth to keep the sensor submerged all the time. But just a note on this, in this example here, if I had the sensor at the bottom and this is my water depth and it was 6 inches, I would calibrate my sensor to 6 inches. If I rotate it up off the side, my water depth is still 6 inches, so you'd calibrate your level to 6 inches. But the other thing is, depending on the equipment, you could tell it that you have it offset, so that way it knows that when, in this case, when the level gets lower than 4 inches, then it tells it to stop reading velocity because it's out of water. Now, as far as you do have the option of using alarming as a maintenance reminder. So I've talked about several things that can determine when there's an issue, either level or signal strength, even temperature. You can use your software. So either have the data push out to a cloud-based software where you can quickly look at it, and so then you can do your maintenance based on the conditions instead of just going out there on a regular basis. So with this, you could quickly look at your data, like in these 3 examples here. I know what my voltage is. They're all around above 10.5 volts. Everything's good there. I don't see any flat lines. So I could actually put off my maintenance until there starts to be a problem. And so with your software, or like in this case, the FlowLink Cipher, you could even have different gadgets on your dashboard that show your signal and spectrum strength. And so when there is an alarm condition, like my ratio starts to drop to 40% or lower, then you can actually have the software send out a text message or an email alarm to let you know when to go out and start doing maintenance on the sites. So how this is going to save you money, instead of just going out there because it's the first of the quarter, you can look at the site, see that all my trends are exactly the same as they've always been. Then you could actually skip that site, and then come back to it later, when you have to change the batteries. So as far as the alarming, just some examples here. You can trigger on different values. So you could tell it when my level is greater than X. So remember, going back to that Flume, my level should always be, we'll say, around 4 inches or less. If I see it go up to 12 inches, well, then I know that's a problem. So that you want to get alarmed right away. And so you can either have your instrument, if you have a modem on there, have that send you a text message to let you know that there's a surcharge condition going on, or you can have the Cipher software send a text message or an email letting you know what's going on. Other parameters you can choose is if your flow rates are less than a certain value, the signal strength is lower. And now, as far as if I start using a signal strength, because I'm looking at the trends, I don't want to be alarmed when there's just an instantaneous reading that dropped low. Because that could have been due to debris or something coming by and I had a bad reading. I don't want to be alarmed on that. So what I would look for is, I would say, if my signal strength is less than 30% over a period of time, like 30 minutes or an hour, okay, now it's consistently staying low. That's when I want to be alarmed. So the different ways to be alarmed is that, if you're pushing the data to a cloud, you can, have it send you a text message, send you an email. If you have data going out to your SCADA system via analog output or Modbus, you should be able to program your SCADA for similar alarms. Now, one other important factor for your flow meter maintenance is making sure you have the latest software and firmware updates. And so, with your cell phones, they're always sending out updates. We're no different. The firmware updates will fix, provide enhancements to the equipment, provide bug fixes. It's going to reduce frustration, because if we already have a fix for it, and you're still struggling with something, might as well fix it right away, get past that, have everything running correctly. When we send out a firmware update, we do have release notes, so you know what changes we've made. And then a lot of people ask, well, how often do we have to update the equipment? We just send out the firmware updates as needed. And then same with the FlowLink software. Now, there is a difference. A lot of people interchange firmware and software. The difference is firmware is a type of software that's embedded into the hardware. So think of it as software for the hardware. Now, sometimes you find that both the firmware needs to be updated on the instrument and a reset is needed. Resets are not required all the time. It's just depending on what was required for the firmware update, it may require a reset as well. But that's only on certain cases. So you don't have to do that all the time. And sometimes the software, like in FlowLink, you need a combination, that maybe they've made a fix in the software and the firmware, and so you may have to update both at the same time. Now, one thing with our DuraTracker, that actually has the ability for remote updates. So instead of going out to the site, if you have a modem on there, you can push the update to the instrument and let it update in the field while you're sitting in the office. So you may be wondering, where do you get the firmware and the software bin files? So if you go to our website, teledyneisco.com, there's several ways to get to it, but what I like to use is just go to the what we do, and you'll see down here at the bottom is the software firmware updates. And that will take you to the next page, which then you can drive down and see the flowmeter software, the different modules, so the DuraTracker or signature, and when you drop that down, then it'll break it down even further into the individual sensors, like the laser flow sensor, the 350 AV sensor. So you'll have a list of all your bin files that you need for the firmware updates. Other things you'll find on this page is over on the right, you can see where you can download your FlowLink software. So if there is an upgrade, you will need your serial number. And you can find that in your FlowLink by going to Help and About FlowLink. It'll show your serial number. We now offer Cipher Go, which is used with the DuraTracker meters. And so if you want to take a look at that, this is a free download. And if you go to our webpage, you can see we have a YouTube video that shows that FlowLink Cipher, and what that's used for is, programming the DuraTracker, retrieving data. You can look at simple graphs on it. So you're not going to use it for the data analysis, but it's a great tool for the field crew for programming and retrieving data, and then telling it to do a manual push to Cipher if needed. And for those of you that didn't know, the FlowCalc app is back, and so we have our beloved Flow Data Handbook. So now we have most all that information on an app, and so you can just go to your app store, download it. It's a free download. I highly recommend getting that. So you may be asking yourself, well, that's great that we have all these firmware updates, but how do I get notified when that updates have occurred? We just released the software notification. So all you have to do is click on the Get Update Alerts. You just have to fill out your contact information, and then there'll be a checklist so you can choose which instruments you want to be notified on. And so that way, when we do have an update on the DuraTracker or 6712 sampler, you'll automatically get notified, and then you can go and download the data.
Well, thank you, Daryl, for sharing your expertise. We are ready to answer any questions that our audience might have. It looks like there are a couple that have been entered. So, Daryl, can you please answer? Thank you.
All right, thanks, Sharon. Yeah, we got just a few that have come in so far. First one I got is, can the AV sensor read level if it's covered with sediment? Yes, it will continue to read the level because it's a pressure transducer. And so, your levels may be elevated slightly because you have the sediment actually displacing the water, but you will continue to read the level. Now the velocity you may struggle with because it isn't able to transmit the Doppler signal out because it's covered with sediment, but you could still get the level readings. And the nice thing about that is, as long as we got the level, you could use that to maybe calculate your flow as the Manning's formula. Next question that came in is, how often do I need to calibrate? I get this one a lot. So as far as, we don't have like a set time that you need to do your calibrations, like every quarter or every once a year. Usually that's driven by local regulation. However, with that being said, I find that most of the times people are going out to their sites because they're required to at least quarterly or twice a year to do their calibrations. That's what I find most common. All right. So let's see here. Next one, for our FlowLink Cipher users, they said they've noticed that there's a number next to the readings. Sometimes when they're looking at the graphs, they move their cursor over it. And so what does that number mean? So what that is, it's a code, and it tells us if the sensor's in error or like it's interpolated data. So mainly going to see that on like the velocity. And so when you move your cursor over it, it may come up with a code 3, indicating that the water depth is too low for it to read velocity. So it's giving you an interpolated velocity instead. And let's see, the next question I got, is there a high and low limit for the water depth? Well, as far as our specification for the area velocity sensors, the laser, the ultrasonic, the range is 0 to 10 feet. And so if we go beyond 10 feet with ultrasonic sensors, it's just out of range for it to get a return signal. Pressure transducers, they can actually, they're calibrated to 10 feet. They can read higher. You lose a little bit of accuracy when you go above that 10-foot range. And then the velocity range is minus 5 foot per second up to 20 foot per second, or minus 1.5 to 6.1 meters per second. Now, one thing to keep in mind with the area velocity sensors, you do need at least 1 inch of water to cover the sensor so it can get a Doppler reading. Yeah, with that, that's all the questions that have come in for right now. If you have additional questions, please use the chat function and send those over to us. And I think Sharon may have some more information on that.
Yes, thank you, Daryl, for handling those questions. And if you happen to have submitted a question and Daryl did not answer, he plans to answer via email. There may be further details to provide. I mentioned earlier, this has been recorded and we will be making this available on our YouTube channel. As soon as it is available, you will receive an emailed link to that. Well, thank you all for joining us, and I hope to see you again next time. Take care.